This is problem number 8-94. Match each equation with the appropriate graph. Do this without using a graphing calculator. So let's look at the equations first. Notice that they're all sine, so that's not really a question. But just look at the equations and maybe see what parts we can find from the equation, what pieces we know, such as vertical shift, horizontal shift, or also called phase shift, if there's a period change, or if there's any stretch factors going on. So let's look at this first one. So A, this has been moved. This part within here is changing the horizontal where it's starting from. It's the phase shift, okay? So the phase shift is going to be when it's nice and easy like this, I can either set this part in the parentheses equal to 0, or I know it's the opposite of this number. So it's going to be negative, or to the left, pi over 2, and there's no stretch factor. So maybe if we want to look at that, where it starts would be to the left, pi over 2. So this one is not starting at pi over 2, it's also moved up and down, so not that one. This one we can't really see negative pi over 2, but maybe this one, no. This one has a negative pi over 2, but it's opening down, okay? So that's probably not going to be our one, or at least it's starting from here. And this one does not start from there. So let's see what else we can figure out. Let's see. Let's just go on to the next equation. So this one, we know this part is not a plus or minus, so that's going to affect the period. So I'm going to set 2x equal to the normal period length, which is like the distance that it takes to do one cycle. So this tells me my period is going to be pi. And I'll write that like that. Okay, so something that has a period of pi, which also tells you this number right here, tells you the number of cycles you see within the normal period of 2 pi. Sorry, I'm doing this one in pencil. So in the normal distance of 2 pi, if we can see there's any place where there's 2 cycles happening, or it looks maybe a little bit more rapid than normal. So the one that looks kind of more rapid, I would say definitely looks like this one. So it's going to start at 0 right here. I'm going to put a point, and it goes up because that's how sine normally goes. Sine normally starts at 0 and then goes up. So, and then at 2 pi, we've seen it's cycled once and then twice. So this one is definitely B. So I'll put that right next to here. That's number 4. So we're done with that one. Let's look at C. C, we have a stretch factor of 2. So that means it's going to be taller. It's like stretched this way like a rubber band up and down. And so normally it's between positive 1 and negative 1. So this one has a normal stretch factor. This one's between 1 and negative 1, so that's fine. This one's between negative 2 and negative 4. That's still a distance that's the same. This one we already used, 2 and negative 2. This one has a bigger stretch factor going on. It's a distance of 4. And remember, the amplitude, that's what this is half of this total distance. So 5 really belongs to C. So that one is gone. Just from that thing, that's the only one that has that 2 in the front, okay? Let's look at D and see what we can figure out. D is a normal sine curve, except it's moved down 3. It had a vertical shift down. So it still starts at 0, 0. It has a normal period of 2 pi, and everything is shifted down 3. So I'd say this one looks like it's down, so it starts at 0. It normally would start at 0, 0, but now it's moved down. Is a normal 1 curve within that period of 2 pi. So this one's going to be D. Okay, so we did that. Now we just have left 1 and 2, and then the equations A and E, which actually look pretty different. So let's look at E. Continuing on with our equation we haven't gotten to yet. We know that it's a negative, so it's going to open down. So from wherever it starts, it's going to open down. We don't know that, but then it's going to open down. Okay, so where it starts is going to be where our phase shift is. So since this 2 has been factored out already, just like before, we can look in here and set that equal to 0, because that's where the normal phase shift is, which is what I said you can do up here, but this one's pretty easy. And this one also is easy since the 2 is factored out. So it's going to start, or our phase shift is at the opposite of this symbol, so positive, or to the right, pi over 8. So at positive pi over 8, So let's look at between these two. Pi over 8 is not on either of these. It's not like labeled on either of these graphs, but this is pi over 2. So this would be pi over 4, and right in the middle of that would be pi to the 8, or pi over 8, sorry. So right here we'd have pi to the 4th, this is pi to the 8th right here. And it's obviously not starting there. Okay, it's not touching, it's not going through that point. Now this one, it starts at pi over 8, positive pi over 8, and then it's going down, which is what we said it should do. So E and number 1 are actually going to be the same. Okay, so that leaves us number 2. And the reason this one's actually kind of hard is because we can't see the negative pi over 2 on our graph anymore, because we said it was going to start left pi over 2. And we can't see that. However, you can see where the cycle starts up again, which is at positive 3 pi over 2. And if I were to go backwards a whole distance of 2 pi, I would be at negative pi over 2 right here. So actually, this number 2 is A. Okay? So that's how we match those up. And I just start looking at the equations and picking apart pieces of information that you can find out. And then kind of process of elimination. And now that we have all of our answers, supposedly you can, if you want to type it in the calculator now to check, that is totally okay.